G'day everyone, so in this video we're going to be looking at rates of change with a graphical representation, specifically part C, working out instantaneous rates of change with this. Okay, so firstly we're just going to go over this question and break down A and B. So the temperature, capital T, degrees Celsius, okay, varies over time, which is the small t, over a 24-hour period, and it's illustrated in our graph below. Okay, so part A, we estimate the maximum temperature. Keyword there, estimate, so it doesn't need to be perfect, and also the time which this occurs. Okay, hopefully this is pretty straightforward. The highest temperature is our highest point on the graph, which is there. So we can just break this down as A. This, our highest temperature, is approximately 25 degrees Celsius. And this is at 1600. Okay, so that's at 1600 hours. Okay, so that's essentially breaking down that first one. Alright, our second question here, part B. The temperature rise between 10 and 14 is approximately linear. Estimate the rate at which the temperature increasing is the period. Okay, so this is actually asking us for our average rate of change. And hopefully remember that's just our gradient. So you can do y2 minus y1 over x2 minus x1. So let's try and find these points here. So 14, that is about here, and 10 is about there. Okay, so yet again, this is another estimate, so we'll just write down our, just remember this is x2, y2, and this is x1, y1. Okay, so with this, we just need to write down our our values that is an estimate. So firstly, our y2, this will be around 22, maybe 22 degrees Celsius. Okay, as it's slightly above 20, but probably not halfway up to 25. So that's about 22. Our y1, that's about 10. Okay, our x2, this one, well, that's given in the question, so this will be exact here. You won't have an estimate. So that's 14. Our x1 is 10. So this then is equal to 12 over 4, which is equal to 3. And just remember, our y value, because it's our change in y, is degrees Celsius. Our x value is T, or hours, I should probably put, because... So that means our unit is going to be 3 degrees Celsius per hour. Okay, with rates, always have your units. Okay, now, part C. This is going over instantaneous rates of change. So yet again, with this, and when you're using a graph, it's only going to be a rough estimate. It won't be perfect because it does depend on where you draw your tangent line. Okay, so we'll just go over this. So just remember that when you've got instantaneous rate of change, this is our tangent at that point. So you need to do the tangent at that point, and then you need to find the gradient of that tangent. Okay, so make sure you do that. So we're looking at when t is equal to 20. Okay, so t is equal to 20 is about here. Okay, so we need to draw a tangent to that line there. So I'm going to try and get out the straight line on this and see if I can get this all right. That was hopeless. I might just try and freehand it actually. So with this, your tangent, it's where it touches that line and keeps going. Probably should have done this before because it's really hard to do on this. Anyway, might zoom in. So, stop moving. So it will look something like this. If you get a ruler out, it is much more accurate. So you'll see we want to have about the gradient of where that 20 is. So then we draw our tangent line and we need to try and get some points to estimate this. So with this, I'll zoom back out again. So we need to find the tangent of that point. So now we just need to pick some points on that graph there. Okay, so I'm going to pick about this point here. Okay, and this point here. And we just work out the average rate of change of this. Okay, yet again, this isn't a perfect way of doing it. It is just an estimate. Okay, so we've done our tangent, and yet again, it probably wasn't the best one, so this one's going to be probably a little bit off further. So first, we're going our first point, or y2 minus y1 over x2 minus x1. So it's of that tangent line. So we'll call this one's about 24, and we'll say that's about 9. And this one here, this one's 18, and let's say 20. Okay. So this goes from 9 minus 20 is equal to 24 minus 18. Okay, just remember that this is degrees Celsius, and this here is our time in hours. So this becomes negative 11 on 6. Okay, so just with this, just make sure you probably do want to simplify this. So this then will turn into, just quickly, about, I've got 1.8. So this one here is equal to about negative 1.83, and this is degrees Celsius per hour. Yet again, that one probably isn't the best one because it is a little bit hard for me to do it on this. So make sure you do get your ruler out. Try and get that tangent line where it just touches that perfectly and then goes at the same gradient at that point there. Okay. So yet again, that's how you do part C, especially your instantaneous rate of change. And just remember, instantaneous rate of change, you need to draw the tangent at that point on that graph and then work it out using your rate of change formula. Okay, pick 2 points on there and work it out. So you will get some variation to, say, answers in the back of the book or that, because it is an estimate. Okay, it is using the line that you ruled. There will be errors. Okay, we as humans are not perfect. You can do this perfectly on CAS and those types of programs. Okay, so make sure you do have a look at how you do it on CAS if you're given a function. Okay, so good luck with that, and hopefully this